Everyone, welcome to Algebra 1. Today is your PlayPosit lesson, and we're going to be covering 1.02, 1.04 through 1.06. So these numbers correspond to the lessons that are in your OMHS, in your online school. So go ahead and grab your notes and we'll get started. So today we're going to be able to simplify an expression. We're going to talk about PEMDAS. I'm sure you remember this acronym. We're going to determine if two expressions are equal, and then we'll be translating expressions. And I laugh every time I see this. Has a math test at school, accidentally packs TV remote instead of calculator. I'll never forget one time I was going into my classroom and when I used to work in a brick and mortar school, I tried to open my classroom door with my flash drive. I had like a keychain that had those flash drive holders on it. And I was legit like trying to put it into the holder. This meme reminds me of that. So thankfully for you guys, you don't have to worry about this either because remember, we're using our Desmos calculators. So that's a web link, so you don't have to worry about not being able to ever find your calculator. So some of the slides we're going to go over, some of you may have already seen this material, but I'm just going to kind of start from the beginning so we can review it all together. So I'm wondering if you have ever changed a tire, or maybe you have seen someone change a tire, or you've helped someone change a tire. These are the steps, more or less, that you would use to change a tire. They're not in the correct order. So I want you to take a look at this and see what you think. You can even pause the recording if you want and just kind of make some mental notes on which picture you think would go first, second, and so on. Now, ideally, we are going to set out the emergency traffic cone here to have safety on the road, right? When we pull over, that would be step 1. Step 2 would be to raise the jack under the vehicle so you can lift the vehicle up. Step 3 would be to go ahead and loosen what they call the lug nuts. So unscrew those nuts here for step 4. And then step 5 is going to be to put the new tire on, although there's no step that said we took the old tire off. That's missing, but you guys know that would come off first. And the last step would be to tighten those lug nuts onto the tire. Now, I don't think there would be any other way to change this tire, really, right? I mean, you're definitely going to have to jack up the car before you remove the tire. You couldn't do it otherwise. You definitely have to loosen the lug nuts before you can remove them, right? So this process has an order in order for it to be successful. And in math, we have a similar process, and that's called PEMDAS. And that's the order in which we simplify things. So before we get to that, we're going to do a quick exponent review. So here's an example. Remember this little number here on the top, that is called the exponent. And when you see that exponent there, all it means is for you to write this number here however many times. So in this case, we have a 2. We're going to write it twice. We're going to multiply 2 times 2, and we're going to get 4. If we had 3 squared, we would write 3 times 3, and we would get 9. So it always means to write the base number however many times the exponent says. So if we had 2 cubed, we would write 2 3 times and multiply that out. So 2 times 2 is 4, and 4 times 2 is 8. So that's our quick exponent review. Hopefully you recall that from last year. Similarly, let's do a quick fraction review. So you guys remember to multiply fractions. Let's practice multiplying fractions first. All you have to do is multiply straight across. So the top times the top, that's the numerator times the numerator, and the bottom times the bottom, denominator times denominator. and you just squish those fractions together. 2 over 6. Now we can definitely reduce this, right? We want to think about what number can go into each of these evenly. So we can divide each of these by 2 and get 1/3. So multiplication, we're just going to multiply straight across, top times the top, bottom times the bottom. So what if you had a whole number times a fraction? Now, I don't know about you, but I like to make the numbers look the same. It looks similar. So let's make the 5 a fraction. You can make any number a fraction by putting it over 1. And then we can just go ahead and multiply. 5 times 1 is 5, and 1 times 2 is 2. All right, so multiplication is pretty straightforward. Let's do some addition and subtraction. So let's try 1/2 plus 3/2. The idea behind addition and subtraction is the denominators must match. So in this case, they do. So we're good to go. 1/2 plus 3/2 is 4/2. When the denominators match, you can go ahead and add the numerators, add the numbers on top. And of course, you guys know this will be 2. Another example might be 3/7 minus 2/7. So because the denominators already match, they're both 7s, we can go ahead and just subtract the numerators. 3 minus 2 is 1. Put it over 7. But what if the denominator does not match? So what if we had something like 1/2 plus 2/3? So because the denominators do not match, we need to make them match. And I think the easiest way to do that, the easiest way to find a common denominator is just to multiply each of the denominators by the other one. So this is our 2. We're going to multiply the 2 times the 3, the other one. And whatever you do to the top and bottom has to be the same, right? Because really, 3 over 3, that's just 1, right? So we just multiplied the fraction by 1. We didn't really change the value. We're just going to change what it looks like. So instead of 1/2, it's going to be 3 over 6. So if we reduced 3 over 6, it would still be 1/2. So the value is the same. So that's why it's allowed. It's allowed mathematically. Now, this fraction we're going to multiply by the other denominator, the 2, top and bottom. 2 times 2 is 4, 3 times 2 is 6. So now that the denominators are the same, we can go ahead and add the numerators, the numbers on the top. 3 plus 4 is 7. Now I'm going to take a minute to show you something pretty cool. I'm going to show you your Desmos calculator. Here's those cats. Let's pull up our Desmos calculator that we're going to use. We're going to use the graphing calculator, but if you look down here at the bottom, you have a keyboard. So we're going to pop that up, and here's our scientific keyboard. So check this out. We can do 1/2, arrow over, plus 2/3. And look, it will give you the decimal answer, 1.167. But if you click this button here, it will turn it into a fraction for you. 7/6. Oh my goodness. Let's try another one. 2/3 minus 6/7 gives you the answer. Turn it to a fraction if you'd like. Now, I show you this because this is a tool that you guys are allowed to use. I never want you to think that I want you to replace your brain with the calculator, right? Because sometimes the calculator is actually not always right. We need to know what to put in it, and we need to know what it means, what the answer means that we get back. So you could use the calculator to confirm your results, but it's there. We want to use it as a tool. And you want to get comfortable using it because this is the one we're going to use all year, and it's the one that will be on your end of course test. Okay, so let's get going with our order of operations. So remember PEMDAS, And these letters all stand for something. P stands for parentheses. E stands for exponent. M is multiplication. D is division. And then we have addition and subtraction. Now you may have also heard of GEMDAS with a G. Some people also use GEMDAS. G would just stand for grouping symbols. So sometimes in problems, you're going to have more than just parentheses. If we look at this example, there's a set of parentheses here. Other examples could also include brackets. So a bracket is just another type of grouping symbol. So that's why sometimes people like to include that G instead of the P. But I'm old school and I always grew up thinking of PEMDAS. So I'm personally probably going to use that one. We're going to work our way inside out, and we're going to follow these steps, and these order of operations is going to help us to solve these problems. And we can always use our calculator to confirm. So we're going to start with parentheses first. 3 minus 4. Remember, when we're subtracting, we're going to take the sign of the bigger number. So this is going to be a -1 squared. And I'm just going to bring everything down. Okay, now we're going to do E. We're going to do exponents. So this 2 here means we're going to write everything on the inside twice. So it's a -1 is what is inside this entire parentheses. So that's what we're going to write twice. All right, going down the list, we have multiplication. So here, when you start doing multiplication, it's good to work left to right, like when you're reading a book. So 2 times 1 is -2. And -2 times -1 is a +2. Now we can do addition and subtraction. -1 plus 2 is 1. So we could try this whole thing in the calculator if you guys want to. You could have that open in another tab so you can follow along. So to clear these out, I'm just going to hit the X's right here to give me a clean spot, and up pops my calculator. I'm going to do -1 plus 2 parentheses 3 minus 4. And here's that little squared button. You'll also see over here there's one with a B. That B will let you do any power. So if you had something cubed, you could choose the B, and I'll show you what it does here. It just takes you up to that spot so you could put any value there. But we are going to do the 2. And the answer is 1, which is exactly what we chose. Not what we chose, what we figured out. Awesome job. It's a great way to just confirm our work. Let's try another one. All right, so let's go over this. We're going to work with PEMDAS. So parentheses, I don't see any parentheses. I do see an exponent, so we have 2 cubed means 2 times 2 times 2. So I'm just going to bring this down. 2 times 2 is 4, and 4 times 2 is 8. 2 cubed is 8. All right, we did our exponent. Multiplication, I don't see any multiplication. Here's division. So -4 divided by 2 is -2. And now we can do our addition and subtraction from left to right. 2 minus 2 is 0, right? So we just have the 8. And again, you could confirm your work in the calculator. Over here, I do have a challenge problem, and we can work through this one together. A lot of times while we're in class, I'll have a challenge problem on the board just in case you've already completed the example and you want to have a bit of a challenge and you have some time. You can always try that. So I'm going to work from the inside out. You can see here we have some brackets. So we have multiple grouping symbols. So the numerator of this fraction is going to become 3 minus 4 is negative 1. Do that first. And then we can do the denominator. 12 minus 9 is 3. Now let's work on that numerator a little bit more. Working from the inside out here with these grouping symbols, the brackets, we have 4 times negative 1. That's going to give us a negative 4. I'm going to go ahead and make that 24. Okay, so of course I'm going to run out of room. I always do this. So that top, now we're going to square the negative 4. So we still have this negative here on the outside, so be careful with that. Negative 4 times negative 4, that's a positive 16. But we have the negative out front, so let's bring the negative out front. And we have negative 16 plus 2, that's negative 14 over 24. So then we can reduce this, right? 2 actually goes into both of these. So we're going to end up with negative 7 over 12. These are kind of fun. Maybe we should try this one in the graphing calculator or the scientific calculator, actually. But it's through the graphing calculator platform. That's why I said that. And let's see what we get. So I'm going to clear this. We're going to, so just be careful. You can use brackets or you can just use 2 sets of parentheses. The calculator will see it the same way. It's just a set of grouping symbols. So we have that, and then I'm going to square it, add 2, and then divide. So look what just happened. When I hit divide, the calculator put it only on the 2. This is what I mean by sometimes the calculator is not as smart as we think it is. You're like, I did it right, I hit divide, but it's only dividing under the 2. We want the denominator to go under the whole thing. So in this case, it's going to be better probably to go ahead and hit enter. So we know this is our numerator. So let's take that numerator and divide it by the denominator. 8 times 12 minus 9. And we'll get a fraction. Sure enough, it is negative 7 over 12, which is the answer we got. All right, so this is another way that we can be asked sort of similar questions in reducing. You see lots of x's here, right? Lots of variables. And we haven't really gone over how to solve this equation in a traditional sense. But because they gave us multiple choice answers here, all we're going to do is plug these values in for x and see which one is true. So let's try 16. We're going to plug in 16 for x and see which, to see if the left-hand side is going to equal the right-hand side. So I'm going to show you guys a really cool way to do this on your calculator. Let's try storing 16 for x. So we're going to come over here and we're going to say x equals, this should work on this calculator. Let's see. It might not. Whoops. Okay, let's try writing 4x minus 3. Yeah, so I can show you guys this on the other scientific calculator. For now, let's just plug in the 16. So 4 times 16 minus 3, and it gives us 61. And then the right-hand side, whoops, gives us negative 179. So we know 16 is not the answer, right? Because 61 does not equal negative 179. So this is 61 does not equal negative 179. So it's not A. So we can try B. Let's plug in 0 for x. This one's going to be easier, right? Because 4 times 0, that just goes away. You get -3. That goes away and you get 13. That is not equal either. So it's not 0. Let's try 1. 4 times 1 minus 3. All right, 4 times 1 is 4. 4 minus 3 is 1. This will be -12 plus 13. And that's 1. Ta-da! 1 does equal 1. That is true. So the answer is C. It's not a bad idea to go ahead and try D because there's a chance that maybe we made a mistake when we tried C. It's always just a good idea. Let's try D. Try all the answers and make sure we've eliminated it. So it's a -3. All right, so this is -12 minus 3. And you guys are probably already using your calculators on this ahead of me. 36. You get -15 equals something big, right? 49. And that's definitely not true. So we're good to go. The answer is C. All right, so now we're going to get to these fraction ones. So I'm glad we did that fraction review earlier. Don't let these scare you. We're going to do them the same way. We're going to use PEMDAS. We'll start with parentheses. Here we have 2/3 minus 1/3. So this is nice, right? Because the denominators match. So all we have to do is subtract the numerators. I'm going to bring this down. 2 minus 1 is 1 over 3. Here we go. Now we're going to square this, right? We're going to do exponent. And you square a fraction just like you do a whole number. You just write it twice. So remember, with multiplication, all we do is multiply straight across. 1 times 1 is 1. 3 times 3 is 9. Now, depending on how you see this, you might want to make this a 3 over 1 so you can multiply straight across. Or maybe you're going to reduce the fraction first. Some people like to do that. You could say, oh, 3 goes into 3 once and 3 goes into 9 3 times. And you get 1/3, right? 1 over 3. Or we can just go ahead and multiply. So we have 7/3. Whoops, that's a funny color. Hold on. There we go. 7/3 plus, you could do 3 times 1 is 3. 1 times 9 is 9. And then just reduce, right, to 1/3. So I wanted to show you both ways. Let me do that over here. So we'll do 7/3 plus 1/3. And the denominators are the same, so you can go ahead and add the numerators, and you get 8/3. All right, let's go over this one. So now we're going to subtract the fractions in the parentheses. So these fractions, the denominators do not match, right? So we're going to have to find a common denominator. I'm going to multiply this one by 2 over 2. And that's because that will give me the 4 that I need to match this fraction. And I know in the other examples we did, we ended up multiplying both fractions by something. And you can totally do that, or you can just multiply 1. The goal is to make them match. And as long as you're doing the same thing to the bottom and the top, you're good to go. So we're going to have a 2 here. All right, now we can go ahead and subtract those fractions. So 3 minus 2 is 1 over 4. And remember to square. We're just going to multiply 1/4 by 1/4. So you get 4 over 16. Now we know 4 over 16, that they must be able to reduce, right? They're factors of each other. So 4 goes into 4 once, and 4 goes into 16 4 times. And that was really nice because now the denominators match. So we can go ahead and add the numerators. 5 plus 1 is 6, and the denominator is 4. Now we can also reduce this, right? 2 goes into 6 3 times, and 2 goes into 4 2 times. So all that work in there is our answer. If you attempted the challenge, here's the answer, so you can check your work there. All right, moving right along, we're going to talk about the difference between an expression and an equation. And I bet you can guess just based on this word, right? So an equation has an equal sign. That is the main difference. And an expression does not have an equal sign. That's all we're going to put there. Those are the main differences. So let's talk about the parts of an expression. I'm going to put an example here. Here we go. So the first thing I want to show you guys is we have terms. This has 3 terms, this expression. Terms are separated by addition and subtraction. So we have 3 terms. I don't want you to think that the 3 is a term and the x is a term. Those are stuck together by multiplication. That's one term. So remember, terms are separated by addition and subtraction. So we have 3 terms. Next, we've already talked about this, but the little number here, remember, this is called the exponent. All right, and I'm guessing from your Math 8 experience or Math 7, you know the x is the variable. So a variable means it can change, right? It can be any number. It can change. Something that cannot change is this number right here. This is called the constant. It stays the same. It stays constant. It's just -1. That number will never change. I mean, unless we do something to it, but like this second term here has the x. So if you put in a 1, then it's 2. If you put in a 2, then 2 times 2 is 4. See how this term can change depending on the variable. So these are some examples of parts of expressions and some words that we're going to use to describe expressions: exponent, variable, constant, and terms. All right, so let's try this example. Miss Winslow pays a babysitter 1 to 2 hours per week to watch her youngest daughter, Sophia, while she attends some meetings. The sitter, who happens to be very qualified, by the way, charges a flat fee of $10 per month. I like to highlight important things on our papers. That helps cover her CPR certification, maybe her gas money, different things like that. And then she also charges $15 per hour to watch Sophia. So of course, this is our important information here. This might even come in handy, I'm not sure. Let's see. The first question says, can you come up with an equation for me to use for budget purposes? So you want to think about what is changing. What value is going to have the variable with it? And the thing that's changing is the hours. This example says 1 to 2 hours, but even if maybe 1 week I wanted her for 3 hours or 4 hours, the hour is what's going to change. So we're going to put the 15 with the x because that's what's going to change. So if you think about it, if she worked 1 hour, it would be $15, right? 15 times 1. If she worked 2 hours, it would be 15 times 2, $30. So that's where we're going to put our variable. The constant, the thing that never changes unless unless the sitter changes her mind, is this $10 per month, that flat fee. So we're going to add on the 10 here. Now remember, that's for a month. And we should probably use this equation then based on the number of hours she watches her for a month. So here's our next question then. In September, she watches Sophia for 4 hours. How much do I owe her? So remember, the hours is the variable. So we're going to plug in 4 for x and solve. So you can certainly grab your calculator for this. That's 60 plus 10. So we owe her $70. Now for 8 hours, we're going to plug in 8 for x. That should be 120 plus 10 equals $130 for 8 hours. So you can see how expressions and equations can be super helpful. This is just one example that I actually have used before. I'm sure you guys can think of a bunch of other examples too that we could use, mostly surrounding money, I would imagine. All right, so this is just another way that you might see this written in your OMHS, in your lessons, and on the SOLs. I wanted to go over it with you guys. They'll give you an expression, and then they'll give you some values. So all they want you to do is plug those in for the variables in the expression. So instead of y, we're going to write 3, and instead of x, we're going to write 1. That's it. Right? And now you have your mathematical expression that you can simplify using PEMDAS, or of course you can also use your calculator as that tool. So 3 plus 9 is 12, and 12 minus 1 is 11. All right, for this one, we're going to plug in 10 for y and 2 for z. So 2 squared here is 4, right? And 2 plus 4 is 6. 10 minus 6 is 4. Okay. So here's another practice question that we have. This time they have 3 variables. So you can see it can just get a little bit longer. But we're just going to take it a step at a time, plugging in what they tell us for each variable. So this is kind of like your key. Okay, so y is 2, x is 7, plus 4, z is 4, and y is 2. There we go. So 2 over 2 is 1, and we just have a bunch of numbers to add together now. I go for tens. This is 10, 8, so we have 18. All right, so let's think about this. True or false? Are these equal? Does the left-hand side equal the right-hand side? And I think the easiest way to confirm that is just to go ahead and do the math. So 4 minus 3 is 1, and 3 minus 4 is negative 1. So this is false, right? This is not equal. Number 2, I know we've dealt with this a lot actually in one of our quizzes and our weekly recap assignment. This exponent only affects what it's directly touching. So this little 2 is touching just this base 2. So this is going to be negative 2 times 2. Only the 2 gets squared. Here, the exponent is touching everything on the inside of the parentheses. Everything. So everything gets squared. So there's a big difference here with the way these are written. When there's no parentheses, it only affects the big 2. So we're going to have negative 4 on the left and a positive 4 on the right. And I want to show you guys that in the calculator as well. So we have a negative 2 squared is negative 4. And then if you square the entire thing, then you do get that +4. So just be super careful with that. I know it can be tricky, especially if we're working fast. So remember that exponent only affects what it's directly touching. All right, so I want you to think of words that would mean these symbols. And you can write those on your paper and follow along. There's so many that would mean addition. Some right off the top, you think of sum, right? Together, maybe more than. And you can certainly pause this recording too and fill out your chart and then come back for the answers. Maybe so subtract, less than, minus, fewer, sometimes fewer, right? Like 2 fewer apples. Multiplication, we think product. And I have another chart to show you after this. So we're going to get the main words here. Division means quotient. Our x is our variable. And then the big buzzword for equal sign is, right? Like 5 plus 4 is 9. So here's our chart. You can add these words to your sections. Some other words. Ooh, increased by, that's a good one. In all. So these are English words that are going to give us clues to what math symbols they mean. Some parentheses words, sum of, whenever you have the sum of, difference of, that word of there, it's going to give you a clue to use parentheses. All right, so let's do it. Let's translate. You can read that meme. Think of a number. Don't tell it to me. Double it. Just say it when you got it. Add 6, half that. Subtract the number you started with. Your answer is 3. Oh, it's so funny. Let's do it. So we're going to translate verbal expressions over to algebraic expressions. So this fancy word algebraic means we're just going to use some numbers and symbols instead of words. So this first one here, 2 less than a number. So we learned in the last slide, less than, the clue for less than is definitely going to be minus, right? We're going to subtract. Well, there's 2 ways to think about this. If you did 2 minus a number, so a number means we don't know what it is, so we'll use x. Or if we did x minus 2, right? Now, which one is correct? Only one of them is right. This less than can be tricky, so that's why I want to make sure to go over it with you guys. If you think about someone's age, and I said, Sharon is 2 years younger than Bob, and Bob is 10. Sharon is 2 years younger, and Bob is 10. What would you say? You would go, oh, 10 minus 2 is 8. Sharon's 8 years old. So see, even though I said younger first, you still take the 2 off the back of the number, 10 minus 2. So even though these words less than appear in the sentence before the variable, we take it off the back of the number. So it is not this one. You're always going to subtract off the back to the right-hand side. And I think that hopefully to you too, it just makes sense mathematically, kind of like the example I said. You have 2 less dollars than me and I have 20. So you did 20 minus 2, right? You don't do 2 minus 20. So whenever you see less than, it's going to come off the back of the number. Other than that, they're pretty straightforward. So number 2, a number minus 2 equals 3. A number minus 2 equals 3. 7 more than 2 times a number. 7 plus 2 times a number. So see, it's just a different way to write it. Now with addition, it's okay for you guys to change the order, right? More than. It doesn't matter if that goes on the front or the back. All right, number 5, the square of a number plus 5. Now I'm using x's, but you guys know that you can use any variable. You can use y, t, z. All right, number 6, 5 times a number is 30. And 16 divided by a number. Here we go. So this time we're going to go the opposite direction. Now these can vary greatly. So it kind of just depends what words you want to use. And I think I'm going to type these if I can. So we could say 9 less than a number. That would work. Right? That's definitely going to be the more complicated way to write that. You could say a number minus 9. Let's try number 2. The sum of a number and 4 is 5. Let me write 4. Number 3, so this is 3 times x, right? Because 3 is written right next to the x. So the product of 3 and a number and 7. All right, number 5. Nope, number 4. Number 4. Ooh, let's do it this way. Let's do 5 less than the product of a number and 2. So it's kind of like a puzzle, and we're working in reverse here. So we did 5 less than. That gives us the minus 5 off the back of the number, a number and 2. Here we go. Number 5. Ooh, the square of a number of some number, we can add a different word in there, and 1 is 8. So sometimes that word and will signify addition. All right, the last one. So we see a division bar, so we're definitely going to use the word quotient, right? So we could say a product of a number and 4 we could say divided by, all divided by 2. That works. So there, you guys remember the chart I showed you. Let me go back to it, this one. So you can see there's a ton of words we can use for these. So your answers may vary, and that's totally fine. The only thing you got to really be careful about is making sure this less than business, right? That if it is subtraction, that number is coming off the back of the variable or whatever it might be. All right, so let's take it a little bit further. We're going to have some just a little bit more challenging translating expressions. So this one, let's read it. 1/2 the sum of a number and 4. So I think we should kind of take it one step at a time. Let's do some highlighting. 1/2 the sum of a number and 4. Okay, here's that word is. So that's a good indicator for our equal sign, right? So 1/2. We're going to add together a number and 4. So make sure we're going to take 1/2 of all of this. So we need to use our grouping symbols. That's what this and helps us decide. So we need to group around that x plus 4. Is 3 less than, less than, you know that's going to come off the back, -3. The quotient of 5 and a number. So the quotient of 5 and a number. All right, so let's write it all together. So this was a doozy. 3 less than that. 3 less than all of this. So that 3 comes off the back of the number. All right, let's look at example 2. Your bedroom wall has a length of 12 foot and, a length of 12 feet and a width of x feet. Write an expression to represent the area of the wall. So let's draw a picture. Pictures are good. So the width is x and the length is 12. It says write an expression to represent the area. So we're going to have to remember the formula for area of a rectangle. I'm sure you guys remember this. If not, it is on your formula sheet for this class, which I will give you soon. You're allowed to use it all throughout the class. You're also allowed to use it on the end of course test. So, but I'm guessing everybody probably remembers this, that the area of a rectangle is length times width. So all we have to do is do x times 12. That's it. You could certainly write it like this if you wanted to, x feet times 12 feet. It's not as common, but it's not necessarily wrong. And I'm going to leave off the equal sign because it told us to write an expression. So remember, an expression does not have an equal sign. Let me grab this yellow. Here we go. And that's it. There's our answer. All right, here's another one. A rectangular picture frame has a width of 9 centimeters. Let's draw it. And a length of x centimeters. Write an expression to represent the perimeter. So remember, perimeter just means that you add up all the edges. It's the distance around the entire edge of any shape or space. So if this is 9 centimeters, we know the properties of a rectangle, right? Then this is 9 centimeters. This is x and this is x. So all you have to do is add them all up. So we'd have x plus 9 plus 9. So you'd have 2x plus 18. And that's it. There's our expression for the perimeter of the picture frame. You guys might also remember perimeter as being 2 times the length plus 2 times the width.